Welcome, welcome. So today I have a lesson for 8th grade right here. This is lesson 8 of the Eureka Math. So we're going to be talking about similar triangles again today. We're going to be tying in dilations with parts from the previous module, transformations. So we're going to be tying together dilations with things like translations, rotations, and reflections. So let's piece those together right now. Let's read the first question together. So it says, in the picture below, we have triangle ABC that has been dilated from center O by a scale factor of r equals 1/2. It is noted by ABC prime we have triangle ABC double prime, which is congruent to triangle ABC prime. So that triangle ABC prime is congruent to ABC double prime. So if that wasn't confusing enough, let me put it in layman's terms, which just means simpler terms. This one is triangle ABC double prime. So A double prime, B double prime, C double prime. And then over here we have A prime, B prime, C prime, and then ABC. These are our three figures. So ABC, the last one, was moved from ABC prime, and then that one was dilated from center O onto ABC. So if we went backwards, it would look something like this. ABC, this triangle, is dilated backwards, something smaller, onto triangle ABC prime. So that's where we are, the second transformation, the dilation from here to here. And then after it's been dilated, we're going to move this triangle ABC prime, to this spot right here. It just moved. Remember, we take it and we move it to the right and then up to triangle spot ABC double prime. That's how we got there. So let's write that as steps. I wrote it up for you. Let's go backwards. So from ABC double prime to ABC prime, we're going to translate, remember that's our word, translate ABC double prime. If you count it, that's 10 units to the left, and then 1 unit down. So we can count that from A double prime to A prime is 10 units left and 1 unit down. So after we translate it, we get from the double prime to the prime spot, and then from here to here, like from triangle ABC prime to triangle ABC, that's simply just a dilation from the origin to our point. So going from A prime to A is, if you count it from 1 to 2, that's a dilation of a factor of 2. And remember, we can make our triangles. There's one. We could do this triangle right here from O to C, and then C to C prime. There's another triangle. I'll highlight that one so you can see it even better. Let's do it in red. So here's O to C. O to C prime. So there's a triangle I made from O to C and O to C prime. And if you count the units, you would see that it's a dilation factor of 2 from one point to the other. You could also tell by looking at its coordinates. So that's what I said. Dilate triangle ABC prime by a scale factor of 2 onto ABC. So from here to here. From that point O, which is 0, 0. All right, you can do the exact same thing on this one right here. The next example, exercise 1. Let's do this one together as well. I'm going to go ahead and pause the video if you're watching from home. But if you're in class, I'm going to pause it as well. Or it's a good time for you to pause if you're at home. Okay, pause. All right, let's read the question together. Triangle ABC was dilated from center O, so that's OO, by a scale factor of 1/2. The dilated triangle is noted by ABC prime. So we went from ABC to ABC prime. That's the first step. Another triangle, ABC double prime, is congruent to ABC prime. So this is ABC prime, this is ABC double prime, these two triangles. Double prime and prime, those two triangles are congruent. That means they're exactly the same shape and same size. Describe a dilation followed by basic rigid motion that would map triangle ABC double prime onto ABC. So let's describe how do we get from here to here. Well, again, we know this is double prime, this is prime, so we're going to go from here to here. Let's go backwards. Well, these are congruent, and they look like they haven't been rotated or reflected, so we're just going to move it. We're going to translate it, go from one point to another. So let's start with 1 point. I'm going to choose B double prime just because, and we're going to go to B prime. Count 1, 2, 3, 4, 5, 6. So that's how I went from B double prime to B prime. Just the XYs, right? Translation, go XYs first and then YYs afterward. So XYs was 6. So we're going to translate triangle ABC double prime. 6 units left. Okay, then, so I'm right here. Let's move up 1, 2, and then we finally got to B prime. So we're also going to translate that triangle 2 units up. Okay, once we do that, that translates it onto triangle ABC prime. All right, that was step 1. So we're here on triangle ABC prime now. How do we get to ABC? Well, looks like a dilation because it gets bigger, right? The shape stays the same, but the size increases or decreases. In this case, it's increasing from here to here. So let's start at the center. Which direction do we go? Towards one of the points, of course. And how far do we go? We keep going until we hit the other point. Okay, how far was that? Well, let's make our triangles. There's our small one. Make our bigger one. Okay, now the triangles are made. Let's find the distance from the original length to the new length. So that was 6 of the original, and 6 was the new, 3 was the original. So from the original to the new, from 3 to 6, that's a scale factor of 2. I just plugged in my formula. Original times scale factor equals new. When I plugged it in, I solved for the one that was missing, scale factor. I solved a one-step equation, and I got the scale factor is equal to 2. So my scale factor is equal to 2. So my second step, first step was translate. Second step is dilate. Triangle ABC prime by a factor a scale factor of 2, or r equals 2, whichever you want to say. And that's how we get onto triangle ABC. There we go. All right, hopefully that was helpful for you to kind of see how we went through the steps. Of course, not all of these are translations, it just says basic rigid motions. So maybe you need to rotate some of these to get to here, or maybe you need to reflect onto some sort of line. Okay, whatever you need, go ahead and look back at your notes, think about which basic rigid motion you will need to solve the next one. All right, take care. See you all tomorrow.